Alright guys, so this is the second part of 7.3. So the first part we were multiplying rational expressions. Here we are going to be dividing. Okay, so just before we start, I want to remind you that when we divide by a fraction, okay, it's the same thing as multiplying by its reciprocal. Okay, I know that's a lot of words, okay? So to kind of put that in more math terms, okay, so say I have 2 divided by 1/2. Okay, we could also write that as 2 over 1/2. Okay, now when we divide by a fraction, which is what we're doing here, it's the same thing as multiplying by the reciprocal. So this would be the same thing as 2 times, this would become 2 over 1, which is 4. Okay, so we're going to do the same thing as here. Okay, so if we look at example 1a, notice we are dividing by a fraction. Okay, so when we divide by a fraction, okay, that's the same thing as multiplying by a reciprocal. So this is the same thing as multiplying by the reciprocal. So we would flip the numerator and the denominator here. So x squared minus 11x plus 30 over x squared minus 6x. Okay, from here, this is the same thing as we did in part 1 of 7.3. Okay, so from here, we're just going to be factoring ninjas. Okay, so this is 7x over 2 times x minus 5 times, this here is what? X minus 6, x minus 5 over x parentheses x minus 6. Okay, so when I multiply it all out, I get 7x times x minus 6 times x minus 5 over 2, don't forget this x, 2x, x minus 5, x minus 6. Well, the x minus 5s cancel each other out. X minus 6s cancel each other out. The x's cancel each other out. So this reduce is just 7 over 2. Okay, now I have to write the restrictions to my domain. So x cannot equal 2. Well, x cannot equal to 0 here, to 6 here, to 5 here. Okay, now notice this was on bottom and this was x minus 5, x minus 6, but 6 would be here, 5 would be here, and we've already covered 5 and 6, so we're good. So x cannot be 0, 5, or 6. Here is our final answer. All right, so let's look at example 2. Okay, here we have 6x squared plus x minus 15 over 4x squared divided by this. Now, some of you guys, this will confuse, and it will help you a lot more if you just put that over 1. Okay, so if I want to go ahead and factor now, we can do that. So if I factor 6x squared plus x minus 15, okay, I want two numbers that multiply to, what is 6 times 15? That'd be 90. Two numbers that multiply to 90 and add to 1. Well, that's, multiply to negative 90. So it'd be positive 10 and minus 9, because negative 9 times 10 is negative 90, and negative 9 plus 10 is positive 1. Okay, so if I want to factor that, I could change 6x squared plus x minus 15 to 6x squared plus 10x minus 9x minus 15, and then throw it in the box. Okay, so it'd be 6x squared plus 10x minus 9x minus 15. So the common denominator here, or sorry, common factor would be 3x, which makes this 2x. This would be 5 minus 3, so it'd be 3x plus 5, 2x minus 3. All right, so if I rewrite this, this is 3x plus 5 times 2x minus 3 over 4x squared divided by, I could pull an x out of here, 3x plus 5 over 1. Okay, now once again, when I divide by a fraction, it's the same thing as multiplying by its reciprocal. So 3x plus 5, 2x minus 3 over 4x squared times, this is the reciprocal 1 over x, 3x plus 5. All right, so now if I put these all together, the top would just be 3x plus 5, 2x minus 3 times 1, I don't need to put the times 1, over 4x squared times x would be 4x cubed times 3x plus 5. Okay, notice 3x plus 5, 3x plus 5, so I'm left with 2x minus 3 over 4x cubed. Now I have to put the restrictions on my x. So anywhere in here that would make any denominator 0, I can't use. Okay, so x can't be 0. Here we're good. I would have to put it in here too, which would be negative 5/3. And then x can equal 0, which we've already covered. So this here should be my final answer. All right, I want you to go ahead and pause this video. I want you to try to work this one out yourself. If you get stuck, look at the one we just did. It's very, very, very similar. So try it on your own and then we'll go over it. All right, so hopefully you have gone through and tried this on your own. So check yourself against what I got. Here's my final answer here. Sorry, I didn't do it. 3x minus 1 over 5x cubed, where x cannot equal to negative 1 or 0. All right, let's look at example 3. Okay, so it says the total annual amount in millions of dollars of personal income earned in Alabama and its population can be modeled by, okay, so here's its population and here is the total amount earned. Okay, where T represents the year with T equals 1 representing 2001. Okay, so find a model M for that annual per capita income. So that's income per person, basically. Okay, so we would start by saying M equals income per person. Okay, so if I just went and put that in, so M equals 6922T plus 106,947 over 0.0063T plus 1. Divided by, I'm going to put this here, divided by P, which is 0.0343T plus 4.432. Okay, just like we've done before, I can go ahead and put that over 1. Okay, now I'm not going to factor this. Yeah, stuff with something this big and then decimals, don't even try to factor, okay? All right, so when I divide by a fraction, this is the same thing as multiplying by its reciprocal. So 6922T plus 106,947 over 0.0063T plus 1 times, I'm going to flip this, 1 over 0.0343T plus 4.32. Okay, and if I put that all together, I would get the numerator is 6922T plus 106,947 over, I'm just going to put these two in parentheses. Hopefully it fits on here. 0.0343T plus 4.32. Okay, so here's our equation. This is what our equation is for M. Okay, now it says estimate the per capita income in 2010. Well, guys, if T equals 1 represents 2001, then T equals 10 represents 2010. Okay, so all we're going to do is plug 10 in for T Okay, and just put that into your calculator. And when you do, you should get roughly 34,707.07. So per person, they earn roughly $34,700 a year. All right, if you feel like you need more practice with these, go ahead and pause this video, work out these monitoring progress, look at the examples we've already done, and then I'll show you the solution. So go ahead and pause it. All right, so here is what you should have gotten.